NIST just confirmed what security teams feared. Nobody actually knows how to monitor AI once it's deployed. Meanwhile, the debate over whether AI progress is slowing down is heating up, and the answer depends entirely on what you think progress means. Plus, why great engineers are using AI to write less code, not more. From the team at the Daily Brief, it's Friday, April 3rd, 2026. Good to have you with us.
We went through about 171 posts, articles, and threads across LinkedIn, Substack, and YouTube to find what actually matters today. Let's get into it.
So let's start with the big story. So here's the thing that stopped me cold this morning. Rock Lambros, he's deeply embedded in the OWASP GenAI security project, flagged that NIST just published AI 804, and the headline finding is brutal. 250 experts essentially confirmed that nobody has a reliable methodology for monitoring AI systems after they're deployed. 250 people who do this for a living, and the consensus is we're still figuring it out.
Yeah, now think about what that means in practice. Companies are shipping AI into production, into healthcare, into finance, into hiring pipelines. And the nation's foremost standards body is saying the post-deployment monitoring playbook basically doesn't exist yet. Lambros also talked about what happened at the OWASP GenAI Security Project workshop, where there were no vendors in the room, just practitioners. And what did the security community actually ask about? Not theoretical attack vectors. They asked about the basics. How do you know when your model starts behaving differently? How do you catch drift before it becomes a liability? How do you even define acceptable behavior for a system that's probabilistic by nature?
This is the gap that keeps widening. We've gotten really good at building powerful AI systems. We've gotten decent at red teaming them before launch. But that middle phase, the part where the model is live, interacting with real users, encountering data it wasn't trained on, that where our tooling and our frameworks are still embarrassingly thin. And NIST just said it out loud, which, credit to them, is exactly what a standards body should do. The question now is whether the industry actually responds, or whether we keep shipping and hoping. Moving on, there's a fascinating debate brewing, and the Normal Tech newsletter has been poking at it from several angles. Their piece is AI progress slowing down, has been getting serious traction, 184 engagements, which for a nuanced technical argument is saying something. And the answer they land on is more interesting than a simple yes or no.
Yeah, and here's the thing. On one hand, the benchmark improvements from one frontier model generation to the next are getting smaller. We're not seeing the dramatic leaps that characterized, say, GPT-3 to GPT-4. The low-hanging fruit in scaling laws may be picked. But on the other hand, and this is where it gets subtle, progress is shifting. It's moving from raw capability gains to things like efficiency, specialization, and what you might call deployability. Models are getting cheaper to run, faster to fine-tune, easier to slot into real workflows. That's progress. It just doesn't make for dramatic benchmark charts.
Normal Tech also ran a companion piece fact-checking Moravec's paradox. That old observation that what's hard for humans is easy for computers and vice versa. And their finding is that the paradox is holding up less cleanly than it used to. AI is now reasonably good at some things we thought would be the last to fall, like certain kinds of physical reasoning, while still struggling with tasks we assumed would be trivial. The neat categories are breaking down.
Right, and what's interesting is, separately, they published a provocative argument that AI leaderboards are no longer useful, and we should switch to Pareto curves. Basically, stop asking which model is best, and start asking, which model gives me the best trade-off between capability, cost, and latency for my specific use case. That reframing matters a lot if you're an engineering leader trying to make actual procurement decisions instead of chasing hype.
Here's something that caught my eye. Gadir A. has been on an absolute tear on LinkedIn, and the through line of their posts is something that deserves more attention than it's getting. The core argument. Most people are using about 5% of what tools like Claude Code can actually do. They're treating it like a chatbot. Type a prompt, get an output, move on. And that's like buying a CNC machine and using it as a paperweight.
Yeah, and here's the thing. One of Gadir's posts that really resonated. Claude feels inconsistent to you. You feel inconsistent to Claude. Gets at something fundamental about how these tools work. If you don't give an AI coding assistant consistent context about your project's architecture, your naming conventions, your testing philosophy, then every interaction starts from scratch. The model isn't being flaky. You're being incoherent. That's a hard truth, but it's the right one.
This connects to a broader point Alexander Zajac has been making. His post, "Great engineers use AI to write less code," flips the common narrative on its head. Everyone else uses AI to generate more code, more boilerplate, more features. But the best engineers? They use AI to simplify, to refactor, to eliminate unnecessary complexity. The productivity gain isn't in volume, it's in clarity. Zajac also published a list of 8 things you need to understand before building AI agents. And while the format is LinkedIn catchy, the substance is real. You need to understand failure modes, state management, human-in-the-loop design, and cost modeling before you write a single line of agent code.
Right, and what's interesting is, Ruben Hassid made a parallel observation about Google Gemini. People are using it like Google search, tossing in random questions and expecting brilliant answers. But these tools reward structure, context, and specificity. The skill gap in AI isn't about access anymore. Everyone has access. The gap is in how deliberately you use these tools.
Now, shifting gears a bit, Normal Tech dropped another piece that I think is going to age really well. AI safety is not a model property. Let that sink in for a second. The entire discourse around AI safety, the alignment research, the red teaming, the constitutional AI approaches, has been largely focused on making the model itself safer, making it refuse harmful requests, making it more truthful, making it less biased. And Normal Tech's argument is, that's necessary, but wildly insufficient.
Yeah, and here's the thing. Safety, they argue, is a system property. It emerges from how the model is deployed, who has access, what guardrails sit around it, how it's monitored. Oh wait, NIST just told us nobody knows how to do that last part. See how these threads connect? You can have the safest model in the world, and if you deploy it without proper access controls in a high-stakes medical context with no human oversight, it's not safe. Conversely, a less aligned model deployed with robust system-level safeguards might be perfectly fine.
This connects to their other piece arguing that AI existential risk probabilities are too unreliable to inform policy. Their point isn't that existential risk doesn't matter. It's that the numbers people throw around, the 10% chance of catastrophe estimates, are built on so many uncertain assumptions that they shouldn't be driving concrete policy decisions. Instead, they advocate for focusing on the risks we can actually measure and mitigate right now. The systemic ones, the deployment ones.
Right, and what's interesting is, and then there's their analysis of 78 election deepfakes, where they concluded that political misinformation is not fundamentally an AI problem, it's a distribution and trust problem. Deepfakes get the headlines, but the actual mechanics of how misinformation spreads haven't changed that much. The vector is social, not technical. It's a consistent worldview. Stop fixating on the model, start fixating on the system around it.
There's another angle worth talking about. Joe Reese, who's become one of the most clear-eyed voices in the data engineering world, published 2 pieces that are worth reading together. The first, 2028, The Great Data Reckoning, paints a picture of what happens when the AI hype cycle collides with the reality of most companies' data infrastructure. His argument is that we're about 2 years away from a massive reckoning where organizations realize that their AI ambitions are completely bottlenecked by the state of their data, messy pipelines, inconsistent schemas, no real data governance, metadata that's essentially fiction.
Yeah, and here's the thing. The second piece is a satirical take on Gartner declaring 2026 the year of context, where everything becomes a context product. And while it's funny, there's a sharp edge to it. The hype machine keeps minting new categories. First it was big data, then data mesh, then lakehouse, now context. And each time, the fundamental problems don't get solved, they just get rebranded.
What makes Reese's perspective valuable is that he's not anti-AI. He's pro-plumbing. He's saying, before you build the gleaming AI application, go fix your data pipelines. Make sure your training data is actually representative. Make sure your feature store doesn't have 3 conflicting definitions of customer. It's unsexy work, and that's exactly why it doesn't get done.
Right, and what's interesting is, Sebastian Rashka offered a technical counterpoint with his deep dive on implementing Qwen 3 from scratch, showing that at the model architecture level, innovation is very much alive. His curated list of LLM research papers from the first half of 2025 suggests the field is producing more papers than ever. The tension between research is thriving, and deployment is a mess might be the defining story of this era in AI.
All right, let's zoom out and talk about the bigger picture. What are the main themes running through everything we covered today? The first big theme is the deployment gap. The distance between what AI can do in a lab and what organizations can responsibly operate in production is growing faster than either the research community or regulators are closing it.
Next, skill over access. As AI tools become universally available, the competitive advantage shifts entirely to how deliberately and structurally people use them, creating a new kind of digital literacy divide among professionals.
Next, systems thinking over model thinking. Across safety, performance evaluation, and deployment, the most impactful insights are coming from people who zoom out from the model itself to examine the full socio-technical system it sits within.
And the last one, progress redefined. The AI community is in the early stages of a paradigm shift from measuring progress as raw capability gains to measuring it as efficiency, cost-effectiveness, and fitness for specific real-world tasks. So if you're going to take away a few things from today's episode, here's what I'd remember.
Number 1, if you're shipping AI into production without a post-deployment monitoring plan, you're not moving fast. You're flying blind, and NIST just confirmed it.
Number 2, the next competitive moat in AI isn't which model you use. It's whether your team has the discipline to use it structurally instead of casually.
Number 3, when someone tells you AI progress is slowing, ask them, slowing by whose definition? The metrics that matter are shifting under our feet.
And finally, fix your data plumbing before you build your AI cathedral. 2 years from now, the organizations that didn't will be the cautionary tales.
That's the daily brief for today. All the sources and links are on the website if you want to dig deeper.
Thanks for listening. See you tomorrow.